In today's screencast, we'll be discussing dunder methods in Python. If you aren't familiar with the term dunder, it's what the Python community affectionately refers to as double underscore methods. One double underscore method you might be familiar with is the dunder init method, which is used when instantiating and declaring classes. So let's just jump right into this. I'm going to cover several dunder methods and hopefully remove the mystery associated with each of these methods and reveal some of their powerful abilities. The first one I'm going to discuss is not necessarily a method, but it is an attribute that is available in any Python script that you run. I'm sure most of you have seen this in offhanded scripts that allows you to create the entry point for this particular method. Now, this will result in, if the dundername attribute of the file is dundername, then the main function will run. But if we import it, the dundername will not be main. So I've written up a little example. It's kind of hard to run this example in IPython notebook, so I've written a little example here. As you can see here in check.py, we have a main method that prints out my name is and then the name of this particular file, and then we have a check to see to make sure it runs. So when we run this particular file just by typing Control B, it says my name is main. That meant that this was true, and then we printed out the name. Now, if we look here in mic.py, we import main from check as m, and then we run it, and then we check to see when we run this particular script is the name dundername is equal to dundermain. And as you can see, when we imported this from main, it did not run its main method, but it did run the main method that we assigned as m in our function, and it printed its name being check. So as you can see, the name here when imported from mic.py, the dundername in check.py is not main anymore. It is check. Next, we're going to cover the dundernew function. So as you can see here, dundernew and dunderinit are very similar. They are run one after another. Dundernew is run first, and dunderinit is run second. You will be very familiar if you've ever written a class in Python with dunderinit. It is basically our constructor. Dundernew allows and is in control of the creation of the actual instance and returning that instance. What dunderinit is responsible for is initializing that instance with actual variables. So as you can see below, we have a class here called positive integer. Its subclass is the int, which is an immutable type, meaning once you assign it, you cannot change the assignment. So once you say, for example, string is a string, it cannot be changed. You can reassign it to something new, but it is fixed as what it is. So we want to modify what the actual behavior of when a string, or an int in this case, gets created. So what we do is we implement the dundernew. We pass it the class of the thing we are implementing, as well, or subclasses, and a number in this particular case. Now, before we create the actual instance, we check to see if the number is above 0, since we're creating a positive integer type. If the integer is below 0, we raise a value error. If not, we return an instance. So we do call new on int, we pass our class in and the number. Then we just would continue like we would any other class. We initialize our variables, and this returns an initialized instance. This returns the instance, and we have a particular function here. So as you can see here, we have number here. Let's uncomment this one and show you that it actually does break. I got to define that first. Let's just first run the example without this written in there, and it outputs 1. We can get the number. Nothing has changed. Everything's good. Now, when we do this, it raises a value error, since when it first ran the new to check to see if there was to check to see if the number was above 0, it wasn't. An exception was thrown. So you will rarely end up implementing dundernew, but in case you run into a time where you do need to subclass an immutable type, that is the use of dundernew. Next, we're going to discuss the dunderEnter and the dunderExit functions. These functions allow you to create context managers like the one below. These are pretty cool when you have to do something on entrance, like open a connection, and on exit, like close a connection. These are very useful when dealing with sockets or with database connections or even opening simple files. First, let's look at how Context Manager is used, and then we'll go and show how then one is implemented. The with statement allows us to assign the return value from the open Context Manager on the file numbers.txt as the variable numbers. So once we're inside this with statement, we can then simply read from the numbers variable, which is a representation of a connection to this file. So we simply read all the contents of this particular variable to the list of numbers, and then we split it. Excellent. So we have a simple list of all the numbers contained in the numbers.txt file. This is awesome. But the thing to note here is that while we're still inside the numbers, the with block, the numbers file connection is still open. So if we print it here, we have a open file numbers.txt in read mode. Now, when we get outside the with statement or the with block, we no longer have an open connection. As you can see here, the variable is still assigned, but it's a closed file number.txt. And that's when the dunder exit is run between here and here. So once you exit the context in which the with statement is available, it exits. So here is where the enter returns. Dunder enter returns an instance of a connection. And here, when we leave the block, the with block, is when dunder exit is run. So knowing this, we can now then build a Context Manager for opening and closing a Redis connection. So we have a class here below, which is Redis. It takes a connection or a string to a database, which in this case is Redis on localhost. It then calls another class which creates a connection and then returns and assigns that connection to self. So on enter here, so we go with Redis, some connection. On enter, we will end up assigning the connection here, which was in the init of this method, which creates a connection, assigns that to the Redis variable. We are then able to set things and get things on the Redis connection. Then on exit, so meaning once we're outside the with block out here, the exit is run, it closes the connection for us, and all's good in the world. This clears up a lot of code and having to deal with exits and having to deal with opening and closing connections. These are quite awesome. I would use them whenever I could. Next up, we have the dunder str and dunder repr functions. The difference between these two is often overlooked, but when I do see a proper representation, it is quite helpful. This is best described through an example. So we have a class person, which takes a name and an age. We then have a repr function, which simply returns a string, which is a representation of the instantiation of the class that it declares. So for example, here we have person bracket name %r, which will then result in the repr version of this variable to be run. And then we have age equals then the repr representation of self.age to be passed here and to be printed. In the dunder str function, we have a human readable version of this name, which will print a person name is %s, which is the string representation of self.name, at age %d, which is the number representation of self.age. So let's declare an instance of this. We have person equals name Madi, age 50. We will then print the string representation, and then we'll print the repr representation of this class. So as you can see here, we have a human readable version of this thing. So a person named Madi at age 50. And then we have the repr representation. Now the main difference between these two, and ideally what you'd like to have, is have your repr representation to be able to be copied like so. So when this shows up in a stack trace or it shows up in a read execute print loop, you can simply just copy it, start a new line, paste it in, assign it to a variable, and then immediately begin doing things like asking for its name. And as you can see, that was excellent. So that is what repr is supposed to do. And dunder string is supposed to do is give you a human readable, easy to read, easy to consume way of looking at a class. Now, when dunder str isn't implemented and dunder repr is implemented, dunder str simply calls dunder repr. Things to note. I used %r here. So if self.name was a complex class, its repr method would be called. But in this example here, we would then have, if we use %s and we were then to call that would use this attribute's str method to return. So it would give us a human readable representation of this complex class, of a complex attribute, if that was the case. So those are things to know. Same thing goes here. It would print the number representation of any attribute passed here. And that is the distinction between dunder str and dunder repr. It is often easy to mistake and overlook the difference between them, but it is often a very nice thing to see in classes and libraries that I use when implemented correctly. Next, we're going to discuss the @total ordering function decorator and dunder equals and other dunder comparators. So as you can see here, we have a class called name, which takes a string name, and we have implemented the dunder equals method. So that will allow us to compare different name objects. So as you can see here, we first check to see if the other thing we're comparing with is of the same instance of what is on the left side of the double equals. If that is true, then we run to evaluate if the length of the name that is on the left side is equal to the name that's on the right side. Now, this is just something that we wrote up just to show how dunder equal works. So all names with the same number of characters will be equal. As you can see here, this is outside of the scope at this moment, so don't worry about it. And let's remove this decorator just to show you how this would work without it being there. So as you can see, that the equal comparator works. Madi and Mikey have the same number of letters, which is 5. When we compare them, the result is true. Now, the other two examples, which is less than or equal to and greater than or equal to, don't actually have any of their associated dunder methods implemented. So when you run it, each time you'll get a different result. Now, what this falls back on is the dunder compare, which is the dunder CPM, I believe. And if that isn't implemented, it falls back on the object identity address. That is where the particular object is stored in memory. So each time we run this, it returns a new object identity address for each of Madi, Kelsey, and Mikey, and it uses that to do the comparison. And each time that's done, they get stored in new spots. So depending where they get stored in memory, this result will keep changing each time. But as you can see, though, since we implemented the dunder equals, that always remains consistent. So let's move in this dunder LT method into the function. Wrong way. I wanted to tab that. Let's move that in there and add the @total ordering decorator. Now, what this decorator allows you to do is not have to implement the remainder of these comparators. Now, by simply implementing one of these, which is the dunder LT, it allows us to programmatically generate the results for each of these ones. This, I believe, was introduced in Python 2.6. So let's run this through and see what happens here. So as you can see here, each of these evaluates to true now, seeing that they're all true statements. Madi is equal to Mikey, Madi is greater than or equal to Mikey, and Kelsey is greater than Madi. So these are all the comparator methods. You should really implement these in classes, especially when you're comparing custom class types. This allows your users to use all these operators, and what really comes in handy is using the @total ordering, so you don't have to constantly be writing more and more boilerplate code. Things to note about implementing these comparators is be sure to check that the instance is of the correct type, and be sure to always look at what you're comparing on the inside as well. So for example, here we're associating the thing on the left side with the right side. If we were to flip these, especially in a dunder LT operator, this would cause confusion for the user who's actually writing it out the proper way. GetAttr and setAttr. These two methods are quite useful if you want to control how things are set and retrieved. For example, if you want to raise an error whenever an attribute is asked for a variable that isn't there, or if you want to limit certain assignments to certain attributes as well. So we have a class called friend, which takes a name and a nickname. We also have implemented the getAttr, which raises an attribute error, just saying that you've asked for an attribute that doesn't exist, and to clean yourself up. We've also implemented a setAttr. This will be overridden by the lower one here, and I'll explain why I've written this one here to show you what a critical error that could happen with setAttr. So we'll skip over this for now, but we'll come back. And then we do an assignment to setAttr here with the name and the value. Now, what setAttr deals with is with the assignment. So when you assign anything to a particular variable, this is called. This is called with the name of the attribute you wish to assign to and the value, much like you would work with a dictionary. Now, when this portion is called, it calls this class. So if you were to implement this, it would constantly be calling. So it goes, okay, assign assign value to self.name. Okay, call setAttr. Okay, I'm in self-attr. Assign value to self.name. Call setAttr. And you'll get infinite recursion, and as you can see here, we'll reach the max recursion depth very easily. So the thing not to do is to have a call to setAttr with an equal sign inside its implementation. So that's the wrong way of going about it, and it is one of the important ones to watch out for, because it's not often as clear when initially implementing it. Now, the proper way to do this is so in this case, we want to not allow my nickname to be Madi the Potty. So no one can be called that with all our friends. No one can be called Madi the Potty. So if the user tries to set the nickname attribute to Madi the Potty, we will raise a value error saying no one calls Madi the Potty. No one calls me Madi the Potty. Now, when it is a legal assignment, we will then call the dictionary of this class, which is retrievable by dunderdict. We will then assign the key name, which is the name that was passed in. So if we were assigning nickname, this would be nickname, to the value of anything other than Madi the Potty. So let's run this example here. So we tried to set the nickname to Madi the Potty. It raised a value error. No one calls me Madi the Potty, but we can very easily just change this to Madi the Body again, or it's already assigned to that, but let's call it Madi Ladi Dadi. Ladi Dade. Okay, and then that'll go through without no problem at all. So these are very convenient when trying to control and encapsulate particular parts of your class. Again, I would use these with caution, but again, great power, great responsibility, and in Python we are all consenting adults. Now, a cool thing that you might want to implement with dunder getAttr might be fuzzy matching. That might be a good example to play around with to understand how these work. I would advise against this in any production code, but it is a cool way of using getAttr. Next, we're going to do dunder Amaro, which stands for Method Resolution Order. This can come in handy when dealing with multiple inheritance to clarify which version of a method will be run. The dunder Amaro will return a list of classes in the order of which the methods will be resolved. So let's derive a little bit of an example here. We have an object called first. We have an object called second, which inherits from first. Third also inherits from first. And fourth inherits from third and second. So as you can see here, when we run this, we get a list of classes in order to resolve the particular function. So when we run a function on the class, it'll first ask, in this case for fourth, if we run a function on fourth, it'll ask fourth, hey, do you have the particular function that we asked for? No? Okay, does third? It'll ask it in the order in which it inherits from in the declaration. Then I'll ask second. Now, if third and second have subclasses, it will then ask the subclasses of our classes. And again, in order. It'll ask first. Since they both inherit from first, it will then ask first finally, and if it can't find it there, it'll ask object. This can come in very handy when dealing with multiple inheritance in production systems. Sometimes these can get quite complex, and if you just need to be clear on what's happening, this is a very handy little trick to keep track of what's going on. So let's quickly change third to a new class called, let's call this fifth. Oh. Here. Pass this here. And then we will inherit third from fifth. And let's run that now. So hopefully that makes sense with what we've been talking about. So we'll check fourth, check third. Then if it can't find it in third, it will check third subclasses. So then we'll have fifth there. It'll check to see if third subclasses, or sorry, parent classes has the attribute we're asking for. If not, then it will move down to second, then down to first, then down to object. So you can see how that cascades and can get confusing if we have multiple levels. That is the use of dunder Amaro. Very handy. Dunder slots. This is mainly used for performance reasons. For example, let's say you have many point instances. Now, we always know that a point will consist of an X and Y attribute and nothing else. Now, when you create instances of the point without dunder slots, these always have dictionaries attached to them, which take up space in memory. This dictionary gives us a lot of power. We're able to assign attributes on the fly to an instance. So, for example, here, we initially had a point P. So let me first explain how the class is set up. It takes two points, X and Y. It assigns them in a init, and in the dunder slots has all the attributes that we can have in our class in the point one class, and it has the same exact init method. Now the difference between the two is that the point one class instances do not have a dunderdict. So what does the dunderdict allow us to do normally? So with a regular class, dunderdict allows us to add attributes on the fly. So we create an instance of point with 5 as the x coordinate and 6 as the y coordinate. Same thing with the point one class. We send that to P1. So when we assign an attribute to Z on P, which doesn't exist in the init or declared anywhere in the class, it is assigned to the dict, and then when we ask to retrieve it later on, it can. So if we were to do things like this, and it's attached to the instance, everything works, it makes sense. Now, with the dunder slots, we aren't able to do that because it no longer has a dunderdict method, which causes the excess use of memory. When you have a low amount of RAM, or you want to have very good memory usage and you know your classes only need X amount of things, slots is a way to limit the size of your object's use in memory. By doing this, they remove the dunderdict. So when you ask for dunderdict here for the P1, it goes up. I don't have a dunderdict. Only things I know about are X and Y. Now, does that mean that we can't assign to X and Y? Definitely not. We can assign to anything that was declared in the slots attributes. For example, here we'll go P1 dot Y is equal to 10, P1 dot X is equal to 9, and then we'll go P1 dot X, P1 dot Y, P1 dot X, and then we'll comment this out so we don't get this ugly error. And as you can see, I gotta print them. As you can see that you can change them. Slots is a really cool one when needing to be stingy with memory. So this concludes our talk on dunder functions. Things to note: they are very powerful, but you have to understand when to use them and how to use them. They can often lead to some wacky edge cases, but if used carefully, they can make you a very powerful Python programmer.